10, 106. Consider the arrangement of bulbs shown in the drawing. Each of the bulbs contains a gas at the pressure shown. What is the pressure of the system when all the stopcocks are opened, assuming that the temperature remains constant? We can neglect the volume of the capillary tubing connecting the bulbs. So this little area right here, we're going to ignore that volume. We're just going to count this volume, and this volume. And so the way to attack this problem is to look at it at parts and to find the partial pressure experienced by nitrogen when it fills all containers, the partial pressure experienced by neon when it fills all the containers, and the partial pressure experienced by hydrogen when it fills all containers. Because remember, a gas fills the shape of its container, and when we open all of these little valves right here, then the gases are going to all mix and fill the entire thing. And so we're going to make three tables of initial and final conditions, for one for each gas. And so this one will make pressure, volume conditions, and we're going to assume that temperature is going to remain constant for all of them. And for this one, we'll make it be nitrogen, then initial, final, and this one we'll make it for neon. And then for this one, we'll make another initial, final, pressure, volume, and this will be for hydrogen. And then what we'll do is we'll find out the final pressure here, the final pressure here, and the final pressure here, and then we'll add them all together, because remember that the total pressure of the system is equal to the partial pressures that each gas exists at. So partial pressure of nitrogen plus partial pressure of helium plus the partial pressure of hydrogen should give us our total pressure at the end. All right, so let's organize the data here. So this is for nitrogen. Nitrogen begins at a pressure of 265 torrs and a volume of 1 liter. When we open all of these valves right here, it will go from 1 liter to 1 plus 1 plus 0.5, or 2.5 liters total. Temperature, remember, is we're going to say just stays constant for all of these. For neon, we begin with a pressure of 800 torrs, a volume of 1 liter, and then when we open everything, it will go to 2.5 liters as well. Hydrogen, we begin with a pressure of 532 torrs, and then we have a volume of 0.5 liters to start with, and then when we open all the valves, it goes to 2.5 liters. So for each one, you can see that volume goes up, and remember, if volume goes up, that means pressure's got to go down, because volume and pressure are inversely proportional, and so we'll have to take each one and multiply it by a ratio to make it get smaller. So for this one, we'll go 265, and the ratio to make it get smaller would be 1 over 2.5. For this one, we start with 800, and the ratio to make it get smaller would be 1 over 2.5. If I multiplied it by 2.5 over 1, I'd make it get larger, and that's not what we want, because remember, volume's going up, so pressure's got to go down. And then for this last one, we start with a pressure of 532, and we have a volume of 0.5 going to 2.5, so to make it get smaller, we would multiply it by 0.5 over 2.5. So then we will find the pressure here, the pressure here, and the pressure here, and then we'll add all three of those together. So the partial pressure of neon at the end, let's do them in order here. So the partial pressure of nitrogen at the end turns out to be about 106 torr. The partial pressure of nitrogen ends up being about 320 torr, and the partial pressure of hydrogen at the end ends up being about 106 torr. So then 106, oh, that's kind of interesting how those both end up being 106, plus 106 plus 320. When we add all of those together, we get 532 torr for our final pressure.